Let's recap some of the concepts from linear inequations and quadratic equations. Now for linear inequations, we will have something greater than something or something less than something. That's an inequation. And we solve inequations very similar to how we solve equations. We can either add, subtract, multiply or divide the same thing on both the sides, or we can transpose one thing from one side to the other side. Very similar, but some differences are also there. So the difference is that for some operations the sign of inequality will be changed. If we have a greater than sign, for some operation the sign will become less than. Now the sign of inequality does not change for some operations, like if we add or subtract by the same number on both the sides, so that will not affect the inequality. Or if we multiply or divide by the same positive number on both the sides, then also there will be no change in the sign of inequality. But the sign of inequality will change if we do one of these things. If we change the sign on both the sides, for example, if we had an inequality where x was greater than y, and if I change the inequality on both the sides, now minus x will be actually less than minus y. For example, if I think of 5 greater than 3, if I change the sign and I have minus 5 and minus 3, minus 5 is actually numerically less than minus 3. Then if we multiply or divide both sides by the same negative number, for example, if I have minus 3x greater than y, then if I move the minus 3 to the other side, that's essentially dividing both sides with minus 3, then the greater than sign will become less than. And another thing, if we take reciprocal on both the sides, again the inequality sign will change. For example, if I had 3 greater than 2, but if I look at 1/3 and 1 by 2, we know that numerically 1 by 3 is less than 1 by 2. Now suppose after solving an inequation, we will need to look at two things. One is the replacement set and another is the solution set. So replacement set will tell us that the variable x will belong to set of which numbers. So suppose if I say x is greater than minus 3, now x, does it belong to a set of natural numbers, whole numbers, integers or real numbers? That will matter to us. So you will find that it is written with this notation. Suppose x and this is belong to. So natural numbers will be capital N, whole numbers capital W, integers can be I or Z, real numbers will be capital R. And once I know the replacement set and I have solved the inequation, I have to write the solution in the set format. I have to write the solution set. Now in case the replacement set x belong to natural numbers, whole numbers or integers, we need to write the solution set in the tabular or the roster format. And for example, if after solving an inequation, the range of values of x is between minus 3 and 4, x can be greater than or equal to minus 3, but x is less than 4. But if x is belonging to set of natural numbers, then when I'm writing my solution, x can only be some natural numbers within this range. So x cannot be any negative number, x cannot be 0. So the only natural numbers in this range are 1, 2 and 3. So the solution set I have to write in the tabular format, where I am writing the elements 1, 2 and 3. But for the same range, if suppose x belong to set of real numbers, then the solution set must be written in the set builder format, because x can have a whole range of numbers. It can have any fractions, decimals, negative numbers, 0, everything can be included. So to write that, we have to write this curly bracket x colon means such that the range of values of x and x belongs to real numbers with closed curly bracket. That's the set builder format. Now for the same solution set, I can also represent it on the number line. For example, in the first solution set, I had 3 natural numbers 1, 2 and 3. So I will draw the horizontal line and mark some integers on the number line. with equal spacing. Suppose you can take 1 centimeter gap between the integers, and then suppose the solution includes the numbers 1, 2 and 3. So I will highlight 1, 2 and 3 with my darkened circles. I will highlight the numbers with darkened circles. So I'll use a pencil for this. Pencil always for number line or any construction and graph work. So I have put 3 dark circles over the numbers 1, 2 and 3. But I also need to include extra numbers on the number line. For example, -1 and 0 on the left, 4 and 5 on the right, to indicate that the number line is a continuous line, it's infinite, out of which the solution includes only 1, 2 and 3. And there are again arrow marks on both the sides indicating the continuity of the number line. Now for the second example, when the replacement set is set of real numbers and the range of values for x is between -3 and 4, and x can be equal to -3 but x is strictly less than 4, I need to mark all these integers, and then over the integer -3 I have to darken the circle because x includes -3, but for the integer 4 I will draw a hollow circle because x can never be equal to 4 but just less than 4, and anything in between -3 and 4 is also included. So I have to darken the number line in between. So I will draw a line little bit of this much thickness, and then I have to shade the region in between. So with my pencil I will just shade this region in between to indicate that all these numbers between -3 to 4 are also included. -3 included but -4 excluded.